Hello everyone, welcome back to my channel. Today we are going to be talking about normalization, which is the process of efficiently organizing data in a database. All this time, we were learning how to represent data first, like a blueprint or something, before going and working towards the actual database. It's like laying out a plan. Right now, we're going to be focusing on making the database more efficient and less space consuming. All right. So the first goal of a normalization is to eliminate redundant data, and the second is to ensure that data dependencies have only related data stored in the table. Like there aren't any unnecessary information stored in the table or repeated information stored in the table twice or thrice or any number of times. All right. So these are the two definitions that you have to keep in mind a little bit while we are discussing about this. A prime attribute must be a member of some candidate key. Means a prime attribute is essentially just any sort of key, be it a candidate key, primary key, super key, any sort of key. And a non-prime attribute is not a prime attribute. That is, it is the opposite of a prime attribute. That means it's not any sort of key. It's just a normal attribute. All right. So there are three kinds of normalization that we're going to be discussing about. There are more than these, but for now we're just going to be, since this is a basic understanding of database systems, we're just going to be discussing about 1NF, 2NF, 3NF only. All right. So the first rule about 1NF is that first normalization is that there has to be no duplicate rows in the table. Also, each cell has to be single valued, or as they say, atomic values. Sorry about the spelling error. So the values have to be atomic. What that means is that some attributes have multi-valued some attributes are multi-valued attributes or composite attributes, right? So you have to, like, the first thumb rule of normalization is to separate out the values that are multi-valued. Like you can't just put one field cannot have more than one values. It has to have just one atomic value. So it does not allow multi-valued or composite attributes. So this is the first thumb rule. The second normalization is that the first, it has to be in the first normalization form, and like it has to satisfy 1NF first, and then all the non-prime attributes have to be fully functionally dependent on the key. So what fully functionally dependent on the key means is that the key has to be the determinant of all the non-prime attributes. The non-prime attributes are the ones that are not a key, that are just normal attributes that do not uniquely identify any row or tuples. So all the non-prime attributes have to be fully functional dependent on what you call the primary key or the key. All right. The third normalization rule is that a table has to be in 2NF first, and it cannot have transitive dependencies. Okay, so what's a transitive dependency? A transitive dependency is something like if X determines Y and Y determines Z, then X essentially determines Z. So this thing cannot be accepted in a third normalization form because this is a transitive dependency. So it disallows transitive dependencies in a table. We'll come back into that while doing the examples, then you'll understand what 3NF essentially means. But I hope you understood 1NF and 2NF first. So at first, if it 1NF has to satisfy atomic, has to all the values have to be atomic. Second is 2NF has to satisfy 1NF first, and then all the non-key has to be dependent on the key attributes, and 3NF disallows transitive dependencies, and it has to be 2NF first. All right. Also, one note about 3NF is that if X determines Y and Y determines Z, with X as the primary key, we consider this a problem only if Y is not a candidate key. If X is if Y is a candidate key, means if it's some sort of a key, then there is no problem with the transitive dependency, and it is essentially in 3NF. But if Y, the Y attribute is not a candidate key, it is a normal non-prime attribute, then it has to be separated out by 3NF normalization, and it has to satisfy the rule of disallowing transitive dependencies. Like for example, this If SSN determines employee number and employee number determines salary, then this is 3NF form. Even though this is transitive, but this is still in 3NF form, because SSN is X and employee number is Y, and Y determines Z, salary is Z. And since Y is a candidate key, this is not a problem. But if Y was a non-prime attribute, then this would have been a problem, and you would have to apply 3NF normalization and separate these tables out. So here, like I said, SSN determines employee number determines salary, and employee number is a candidate key. So this table is acceptable and does not have to be applied 3NF normalization on. So let's look at some examples. Like I said, 1NF allows only atomic attributes. So as you can see, atomic values. So as you can see, like in the first row, biology and math, these are two values in one row, sorry, in one column of a table. So this is not allowed according to 1NF rules. So we separate them out and put them in a separate table. So Adam 15 will be written twice, but with the subject the same, but it's separated out. So this is just 1NF. This is like a simple form, and this is essentially how you apply 1NF normalization. The second normalization rule is that if there is one primary key and all the non-prime attributes are not fully functionally dependent on the primary key, then you have to separate them out. For example, as you can see in this table, SSN and P number determines hours, but P number only determines P name and P location, and SSN only determines E name. So what this means is that SSN and P number is the primary key. Alright, so hours, E name, P location, the other non-prime attributes have to be fully functionally dependent on SSN and P numbers, this is the primary key, to satisfy 2NF normalization. But since all of these non-prime attributes are not fully functionally dependent on the prime attribute, we have to separate the ones that are dependent on the keys. So after 2NF normalization, SSN and P number determines hours. That's fine, because this primary key determines these non-prime attributes. SSN determines E name. So this is a key, primary key of this table. In this table, the primary key is SSN. So this 2NF normalization is satisfied, because like as it states that the primary key function determines the non-prime attributes. Also here, after separating it out, P number is the primary key in this table, in this separate table. So that's why it also satisfied 2NF, because the primary key satisfies the primary key determines the function determines the non-prime attributes. So this is also satisfied. So in one table, all the primary key attributes have to be, all the non-prime attributes have to be fully functionally dependent on the primary key. So after separating out, this is possible, but without separating, some are functionally dependent and some are not. That's why we had to separate them out with 2NF normalization. Now with 3NF, 3NF normalization states like you have to be in 2NF form also, and there can be no transitive dependencies. In this table, student ID is a primary key, but street, city, and state depends upon zip. But zip is not a key. Zip is not any sort of key. The dependency between zip and the other fields is transitive dependency. Hence, we have to separate this table out. If zip code was a primary or some key attribute, maybe a candidate key or something, if it was any sort of key, then we wouldn't have to separate these out. But since zip is a key attribute, like is not a key attribute, we are having to separate this out, and in this table, zip becomes a key attribute. In this one table, only student ID is the key attribute, but in this table, zip is the one key attribute, and in this table, student ID is a key attribute. I know this might be confusing, but now we're going to be solving a problem to clarify this further. All right. The question says that in the car sale, these are the fields given. Assume that the car may be sold by multiple salesmen, and hence car and salesman these together form the primary key. Additional dependencies are car number determines date sold, car number determines discount amount, date sold determines the commission, the discount amount, and sales number determines the commission percentage. Now, as mentioned above, the car number, the first step, if the primary key is not given, but since it's given in this question, the first step would be to determine the primary key, because from there we'll move forward and we can do the 2NF and 3NF normalization. As you can see, it is this relation is in 1NF because all the attributes are single and atomic values. So let's write this down. Satisfies 1NF because all values are single atomic values. All right. So now the relation is not in 2NF because car number determines date sold, fine. Car number determines discount amount, fine. But sales number determines commission. And as mentioned before, the primary key is car number and salesman, right? So thus these key attributes are not fully functionally dependent on the primary key. Like they're half partially dependent. Like the date sold and discount number are dependent on car number, and commission percentage is dependent on salesman number. But all of the non-prime attributes have to be fully functionally dependent on car number and salesman together in order to satisfy 2NF normalization. So how do we satisfy this? We can just separate them out. Like we have to separate them out in such a way that each table has a primary key attribute which functionally determines the non-prime key attributes. So let's put car number, like for the table number 1, let's write down for after 2NF. For table 1, we get car number, date sold, discount amount. That's it, because car number determines only date sold and discount amount. Now this we don't need to put in a separate table, because as I said, every table needs to have a primary key so that all the non-prime key attributes are functionally dependent on the primary key. So as in this table, primary key is car number, so date sold and discount amount are dependent on car number. So for table 2, we have salesman number and commission percentage. All right. Now for table 3, we need to have the primary key attributes, because this is the only way that table 1 and table 2 would be related together. Like these two tables still need to have a relationship with each other, because initially this was supposed to be the relation name, car sale. This is supposed to be the whole table. But since we separated them out, we need to have some sort of a relation between these two tables somehow. So we just list all the primary key, like we used to do in schema diagram. I hope you remember this. In schema diagram, while we had some two entities here and they were related, there was one way we could relate them is that make a separate relation with the primary key of the one entity and the primary key of the other entity, and form a separate relation with that in order to relate them together. So this is how 2NF normalization is done for this. Now let's see if this is in 3NF normalization. In 3NF, what this would do is car number determines date sold, and date sold determines discount amount. This was not given. This I had to find it out. In the exam paper, this would not be mentioned. If it was, then you could definitely easily identify and solve the problem. But you have to see a relation in such a way, like all these dependencies are given, you have to find a dependency that shows signs of a transitive dependency. Now as you can see, car number determines date sold and date sold determines discount amount. This is like a transitive dependency because A determines B and B determines C. So this is not in 3NF. Why? Because if date sold was sort of a candidate key, any kind of key, like a candidate key, a prime attribute, then we wouldn't need to separate them out or nothing. Like this would have been like enough. This up to this, the table would have been enough to satisfy our needs. But like we would just call it 3NF normalization. That yes, this table satisfies 3NF normalization. This table, as in I'm talking about this table. But since date sold is not a key attribute, it's just a non-prime attribute, we have to separate them out and apply 3NF normalization. After 3NF, we get one table, table 1. We get car number determines date sold, car number and date sold. We put this in one table. We separate them out, and we separate date sold and discount amount. This is table 2. And table 3 would be salesman number and commission, like as before. Salesman number and commission percentage. And table 4 would be the relation that we formed before, which is this. Because like I said, we have to somehow relate all these tables together, and this is the only way we can actually do that. If you want to relate 3 and 4, we could relate it because these two are common values. If we want to relate this and table 2 and 3, then we could do so with the help of this table. If we want to relate table 2 and 1, we could do this because date sold and date sold are common attributes. All right, now for this to be more precise, we have to underline the key attributes, because only then we can understand that these are the primary key. These are the primary key of this table. This is, I guess, underlined. Let's just ignore. Yeah. So here also, these are the primary key. This becomes a primary key because we have to somehow, like I said, the transitive dependency is only satisfied. The 3NF normalization is only satisfied if, wait, let me just, yeah. Okay, the 3NF normalization is only satisfied on its own without solving, without doing any normalization, only if in the transitive dependency, the value on the right hand side, that means when A determines B and B determines C, then from there, if B is a prime attribute, then we wouldn't need to apply 3NF normalization. It would on its own satisfy 3NF normalization. But since the B, as in date sold, is not a prime attribute, it's just a non-prime attribute, that time we would have to apply 3NF normalization. So I hope you understood normalization concepts. This is like a basic concept. I hope you can solve questions like these if they come. And please like and subscribe if you want more CS tutorials, and good luck.